Number 17. Here's the graph of a cubic function. It says what's its equation? Well, there's different ways. You could do it formally all the way through, get to the answer. Maybe I'll do that just for the practice of it. Or you could examine certain features of it. Or you could say, well, take the point 1, 2. If you put x equals to 1 into these equations, which is the one that gives you 2 as an answer? That would do. But there's a couple of things you could do rather than write out the derivation formally. You could say, well, that's an upside down cubic. A cubic graph should look like this, which means it should have a negative coefficient, so it's either A or B. And the other thing is, well, if it cuts the axis at -1 and 2, then the roots are -1 and 2, and the factors should be x plus 1 and x minus 2. So those two things together would do, wouldn't they? Which ones have got x plus 1, x minus 2, and a negative overall? That's A. It's the only one that does that. So the answer's A. If you were to do it formally, which you wouldn't really because that was sufficient to do it, then you'd be setting out like this. You'd say, well, if those are the roots, if the roots are x equals -1, 0 and 2, that means the factors to find y must have been, well, x minus 0 is just x. You've got x plus 1, x minus 2, but there might have been some constant that disappeared during the original factorization. In order to find that constant, I need some other point. Those points are no use because if I put in either x is -1, 0 or 2, one of these terms will go to 0, and then the whole lot will disappear to 0 because it's a product. So you could pick the point 1, 2, which means if x is 1, 2 for y will be k times x is 1. Here, if x is 1, then the answer is going to be 2. Here, if x is 1, the answer is going to be -1. So that says 2 equals -2k, so k equals -1. So there's the formula. K is -1, so it's -x times x plus 1 times x minus 2, which would be answer A. However, you didn't need to set all that out because it was just paper 1, and you could have got that fairly quickly just by inspection. It's upside down for a cubic, so it'd have to be negative, and you know that that should be an x plus 1, so I must make it A. Number 18. Here we've got a quadratic. It says the graph of this quadratic, so it'll be a parabola. It says for what values of x is this graph, is this parabola above the x-axis? Well, you know what it looks like from this. And x times x is a positive, so it's a positive x squared, so it's the correct way around if you like. I know that it cuts at 3 and it cuts at -5, and it's the correct way around. So when it says when is it above, well, here's when it's above. So it's above, but it just says above, not on or above. So that's not including the 3 and not including the -5. So it'll be above if x is beyond 3 or before -5. In other words, x has to be less than -5 or x has to be greater than 3. So which one's that for number 18? It has to be less than -5, greater than 3. That's part C. Written that particular way. Some of the other ones have been written as one single expression. To write that as one expression would be this. If I put the -5 there and the 3 there and have the x between the two, just make sure the signs go the correct way. It's to be greater than the 3, so it's pointing down to the 3. It's got to be less than the -5, so that sign would point that way to say, reading this backwards, x is less than -5. However, that's the way I had the answer, so that kept it nice and easy. Number 19. Which of the following diagrams, and there's 4 shown here, represents this graph? Well, that graph hasn't been stated, that equation isn't explicitly expressed in terms of y, so I need to rearrange it to read y equals before I consider its graph. Well, that's just a case of applying the inverse. The inverse of log base 3 is 3 to the power, so that'd just be y equals 3 to the power x. So the graph should look like the typical exponential graph. It should look like this, cutting through a 1. I'm going to just check which of the answers have we got for this one then. Oh, so we should have put a point on it, of course, because if x is 1, then 3 to the power 1 is 3. That means I've got the point 1, 3. So it cuts through 1 and 1, 3. But it's only the one that did that anyway. So it's this one here, C. Number 20, a list of multiple choice here. On a suitable domain D, well, doesn't refer again, a function g is defined by this expression here. It says which of the following gives the domain and the range. In other words, what can you put in and what can you get out? Well, you can put anything in that you like as long as it gives an answer. Because of that square root, I can't just put anything in. If that's a square root, that means its content has to be greater than or equal to 0. So in other words, x is greater than or equal to 2. So that would be the first part. I can put in any number equal to 2 or above, and it can be any size because that's not the inverse of sign. You can work out the sign of anything, positive or negative. The next part then would be, what answers would you get out? Now, the sign of anything is between 1 and negative 1, which means if you then square it after having evaluated it, it'll still be less than or equal to 1, but it'll be greater or equal to 0 because squares are always positive. The lowest they can be is 0. So the two parts would be this then. X, for a domain, I can put any number x in, equal to 2 or above. And as a range, g of x is going to lie between 0 and 1. Also being equal to those, which gives me, from a set of answers, D.